The Earth is about to spin faster than usual this August and July. Could we actually lose time and not even notice? This isn't a sci-fi movie plot. Scientists have confirmed that Earth's rotation will speed up on certain days in July and August. Do you ever feel like time is moving faster these days? Well, that might be because something weird is happening to the Earth. Okay, so we know that Earth rotates. At least most of us do, unless you are a member of the Flat Earth Society, in which case, welcome. But assuming that the Earth is in fact spinning, we know that it spins once every 24 hours, right? Well, not exactly. The rotation of the Earth isn't fixed. It can speed up and slow down at different times. And right now is one of those times. The Earth is spinning faster than ever before. Well, more specifically, this is the fastest it's rotated in the time since we've been officially measuring the Earth's spin, which only dates back to around 1970. So, before we learn about more about this, if you don't subscribe to my channel, just subscribe. Okay, let us start our video. So really is the fastest the Earth has rotated in at least 55 years, and the speed of the Earth's rotation has actually been accelerating since around 2020. If the flat earthers are still here, well, I'm very sure that there is a conspiracy about how that lines up with global events. And then the shortest day ever recorded came in July 2024, with the Earth rotating a full 1.66 milliseconds less than 24 hours. The blink of your eye is average between 100 to 150 milliseconds. So yeah, 1/100th of a blink. I think it's hard to even notice it. Anyway, let us get to the big question. Should we panic? While we consider this, if you zoom out way behind the 20th century and go back in time, the Earth is actually spinning much more slowly than ever before. 600 million years ago, one day only lasted 21 hours. Well, it's pretty confusing, right? So here is the deal. There are many factors that affect the rotation of the Earth. Also, our Sun and the Moon are big players to our Earth. But also the Earth's own composition can change how fast it spins on any given day. The Sun is really big, but it actually has a pretty minimal effect on the Earth's rotation. If anything, energy from the Sun actually pushes the Earth to spin faster, but it's greatly outweighed by our closest neighbor, the Moon. That thing actually has a very strong effect on how fast we spin. Well, most of this happens through something called tidal friction. This is a very simplified explanation of how that works. So, the gravity of the Moon pulls on the water in the oceans and makes a bulge. This was called high tide. And as the moon circles the Earth, it pulls that bulge along with it, except the Earth itself is actually spinning faster than the orbit of the Moon. So the bulge is lagging behind the speed of the Earth, and that will actually work as to slow the Earth down. It adds about 2 milliseconds to the length of the day every 100 years, and over a long enough period of time, it will eventually slow the rotation of the planets until it matches the orbit of the Moon. But literally everything on Earth will be dead by the time that happens. So for now, don't worry too much about it. On average, the Moon makes the Earth spin more slowly, but right now, the Moon is also one of the factors making the Earth spin faster. The Moon doesn't always orbit around the middle of the Earth. For sometimes it wanders up to orbit closer to the poles, and right now is one of those times. We call that as declination. Getting closer the Moon is to the Earth's pole. The higher the declination, and during these times, the Moon is pulling less on the middle of the Earth and more on the top, which actually causes us to spin faster. But this circles of the Moon is normal. So it's not the only thing that could explain the Earth is moving faster than it has in decades. And for the final pieces of the puzzle, we have to look at the Earth itself. The distribution of mass around the planet is going to have a significant effect on how fast we spin. Well, think about a figure skater spinning on the ice. When the arms are open wide, they rotate slowly. Also, when they pull the arms in, they got accelerated. It was same goes on our Earth too. Like earthquakes can cause the Earth to spin faster. Typically, what happens is you get one tectonic plate slipping underneath another one that drives more rock down under the surface of the Earth. So many mass moving towards the center leads to faster spin. But now we are talking about very small amounts through the Japanese earthquake in 2011 accelerated the Earth's rotation by 1.8 microseconds. That was just 1/100th of a blink, a very small amount, but this all adds up. Water also has an effect on the distribution of weight around the world. Yes, we can blame this on climate change, but this happens in a really strange way. So it all happens because of polar ice caps or melting. That puts more water in the ocean in spite of what the Mel Gibson might try and tell you because the ice is on the land right now and when it melts then it can flow down into the water. But in this case, when we have more water moving from the poles to the equator, it's like a figure skater reaching out with the arms. It's supposed to slow them down, but there is an even greater effect cast by the weight of the ice on the polar regions. You see, these ice caps are huge concentrations of mass and the Earth's gravity pulls them in towards the center and that force is actually enough to squeeze the Earth a little bit and make the entire planet bulge out in the middle. That's way heavier than just the ocean water. But as the ice caps melt and the weight is distributed more evenly, the Earth is getting less squeezed, becomes more circular, the figure skater's arms come in, and we spin faster. Anyway, what does this all mean? Well, since the Earth has normally been rotating slower over time, but we have been adding limb seconds to the standard day in order to keep it in sync with the Earth's rotation. This has happened a few times now, the most recent limb second occurred in 1960. So when we say that one day is 24 hours, we are actually rounding down slightly. It's really 24 hours and a few seconds. But if the Earth continues to accelerate its rotation, then we might end up eventually having to take one of those limb seconds away, essentially bringing the length of a day back down closely to where it was when we started measuring the Earth with atomic clocks back in 1917. Now, unless you are the person in charge of the GPS network or some other critical timekeeping software, I wouldn't worry too much about it. There is definitely much more concerning stuff that's happening on the Earth, but this one is kind of fun to know about. Now, here is the something really cool. This is a video taken inside the Sun's atmosphere. It was just released by NASA and the images were recorded by a spacecraft called the Parker Solar Probe. That was what we are looking at here is the Sun blasting out electrical charged particles into space, while the big cloud-like structure is a piece of the corona. It's like the outer surface of the Sun and everything that you see blasting past the camera is the solar wind. It's the constant stream of electrically charged particles that range across the solar system, essentially creating solar weather. The Earth is mostly protected from this stuff by a magnetic field, but so often a big chunk of this corona gets kicked out into space by the Sun's own energy, a coronal mass injections, and sometimes those will hit the Earth, casting auroras in the northern sky. And if the injection is powerful enough, it can also mess with our electrical grids and communication systems. So we know for a long time that this happens, but right now is the first time that we've seen it up so close. The Parker Solar Probe was launched in 2018 and it had the goal of reaching closer to the Sun than any man-made object before. Also, it would essentially be the first thing to touch the Sun. That happened when the spacecraft made its first close approach to the Sun in 2021. When it entered the corona for the first time, then the probe would fly out to Venus where it would use the planet's gravity to slingshot itself back towards the Sun, getting closer and closer to the star with every pass. Currently, the Parker Solar Probe is just over 6 million kilometers from what we consider the surface of the Sun, which is far below the corona. This is as close as the probe will get, but right now it doesn't have any enough fever to keep flying around Venus and accelerating it, but it's already moving fast enough that it wouldn't get pulled into the Sun or anything like that. So it's going to keep making these close passes through the atmosphere and collect as much data along the way as possible. There are a few important things that we are trying to learn with this probe. But this one is really a weird fact about the sun that we don't understand is that the surface of the star is actually much colder than the outer corona layer. So it's about 5500 Celsius on the surface of the sun, but when you get out to the corona, it heats up to millions of degrees. Sounds kind of strange, right? You would think that if the sun is the source of all heat in the solar system, then it would come from the middle. But it doesn't. The heat is actually on the outside. There is also the mystery of the solar wind. We know that it exists, but we don't know how it exists. We don't understand the force that creates the wind or what accelerates it out into the space. So we are trying to follow the origins and the movements of those electrically charged particles. And even if we can't understand the solar wind, we do want to get better at predicting it. Right now, we don't know if a coronal mass injection is coming until it's already on the way. Also, that thing doesn't give us much time to prepare. Most of this just cause some pretty lights in the sky and maybe a glitch on the power grid. But eventually, a giant solar storm will come, and when it does, we are going to find out what life is like without internet, without electricity, no communication of any kind. Things wouldn't go well. So to wrap that up, don't worry about the Earth's rotation is perfectly alright. Also, do worry about the sun because it might kill us all. There is probably not anything we can do about, but we might be able to at least see it coming, which might be worst in case. Also, before I end the video, I'd like to ask you a question, guys. Did you feel time is moving fast? If yes, comment me in the comment section below. So if you like this video, just subscribe, like, share. Bye everyone.